top-down design. We'll be going over two different methods of doing top-down design and setting up the file structure. So I'm going to start off with creating an assembly file. And I think I'll turn on all my datum feature tags so we can see them. Turn this a little bit. I've got this in isometric. Maybe I should go back to trimetric. It's always good to do that when you start a file. Oh, I don't want to save that. Let's see if we get it. There we go. All right. So basically what we're going to do is we're going to do some top-down design. First thing I want to do is show all the filters for the model tree items. Turn them on all of the display items on. And then what we're going to do is we'll use a traditional method first, and we'll use another method second. I think one of the things I want to do, though, is I want to move my datum tags a little bit just so that we can have them a little bit away from them. Actually, you don't have to do this so much to the assembly anymore as you have to do it with the parts, but we'll do it with both. All right, so we are going to create a component in the assembly mode. And this is part one. I guess we can just use the default name. And we're going to locate it coordinate system, and align the coordinate systems. So I can select it off the screen or over in the model tree. And you can see what happens is that it puts the little green dot here and identifier that it is the active part. You can also see that all the features for the assembly have been made transparent and light. So this is our first component. And again, I think this is where one of the things I should do is I should move the datum tags a little bit. And I think also in this case we should be changing the name. And we'll call this one PT1. And again, I'm going to move them a tiny bit. Don't move them very far because you're actually in a pictorial rotated view, and when you rotate the model, you'll see that these are in a much different position than what you think. Usually farther away than what you anticipated. So that's our first component. And now we'll go back up to our assembly, activate it, and we'll create another component. It's number 2. And coordinate system to coordinate system again. And I think you can see what happened here. That's when we moved the datum planes. They have the same name, so they're a little bit different in position now, so it's easier to see them. But we'll leave these as the default right here. All right, now I'm going to go back over to my first component and activate it. And I'm going to create a simple part. Extrude. Sketch view here. Got a couple of references. You can see the datum plane DTM1 and 2. And you'll notice it's DTM1 and 2, not top, front, and right. So we're sketching on DTM3. And what we're going to do is just, let's put a construction center line down the middle here. And make a simple part. Just half. And window it in. We will mirror it. I'll go to my pictorial view. Check. Let's make that symmetric. I'm using default values. I know this is a very large part, but we're just doing the concepts here. So there is my first component. It's active. You can see it here. So let's go over and change the appearance and get a different color on there. And maybe we'll go to shading with edges to make it show up a little bit better. So there's our first component. Now I'm going to activate the second component. And we will do the same thing. We'll create a feature. And in this case, you're going to be wanting DTM3, that component. And the most important here is our references. And we're going to make this component completely dependent on the first component. So it will have all external references. All right. So let's create our component. And we might as well make something equal. Let's make this and this equal. See if we can do that. Maybe not. Because of this situation. So I don't think I could. No, there we got it. L1 equals L1. I didn't do it in the right direction. All right, so there are no dimensions on this. Check. Standard orientation. Again, let's make it symmetric. But in this case, actually, we have to go and make it to selected on both sides. Like so. And this is the active part, so again, we can go and we can change the color here. Try this one. All right. Okay, so let's activate the assembly. Got a couple of parts here. Stuck together. No constraints because we're using external references for it. And I think what we're going to do now is we'll put in a hole, but this is an assembly hole. And we will locate the hole just to place it in the very middle. And we will align it so that it is locked into the center. And then we're going to use our through all handle here. And here's our hole. Now, if I go and open up this part, you'll see there's no hole because it's an assembly level feature. And you can see the cuts here. So if I click on the hole and I click on insert, right mouse button, insert, intersect, and let's uncheck that up there. Let's make this the part level. Click these options on. Okay. So now, either one of these I open, you'll see the assembly hole visible in it. All right, so this is one method. The drawbacks are that you have DTM 1, 2, and 3 rather than top, front, and side. At any point, though, in this particular case, let's delete this component, and you can go back and you can assemble it in the traditional manner. Let's do this one. And let's just pick, how about in here for the third one? Coincident. There we go. Fully constrained. And now it's in the traditional constraints as far as its placements goes. Coincident, coincident, coincident. So, a little bit different. If you go over here, you'll see that there's no placement because it's all set up with external references when we were making it. All right, so let's do another one. We'll use the default values again. I'm not going to bother to move everything. You see the point of doing that. Tree filters, we do want to show a couple of things. We'll just be lazy this time and turn those on. Only those on. And we've created an assembly. But what we're going to do is we're actually going to go now and create a part. This is part number 3, by the way. And we'll create another part, part number 4. And we can close those 2 parts. So now here we can actually assemble part number 3. And let's go default, in other words, coordinate system to coordinate system. And we'll do it again. Now a lot of companies prefer this method. It's basically the same thing as when you're ready to go here. It's the same thing. You have 2 components and you have the assembly. So let's pre-select, or actually let's activate component number 1. Select for sketching. We'll do an extrude again. Pretty much the same method as before. Let's put our construction center line down the middle. And let's make a let's do it this way. I want to use a arc, and I could go center and ends. Let's do that. And it doesn't make any difference exactly what we're doing here. We're just coming up with a shape. All right, that's pretty good, except for I actually want this to be up here a little bit, and maybe these down a little bit, like so. All right, and I'm just going to come in here and I was hoping to get the halfway mark, but I'm not going to do it. So I'll have to add a couple of constraints. These are across from each other, but it's not symmetrical, so I'll have to do that. Not maybe the best methodology and how I was doing it, but that looks okay. There's too many. I'll leave one in. And again, you could change the dimensioning scheme and whatever, but oh, it looks like I did not get symmetric. I got symmetric here, but I'm not sure why I'm still getting a half dimension. I'll leave it anyways. That's not the point of the project here. What we want to do is just extrude it like before, and symmetric. And there's our first component. And again, we can change the color. Maybe we'll go find a different color. You may not have this capability. It depends on your system. All right, so there's our first component. Now we're going to go over and we're going to activate the other one. And we're going to build, of course. I wonder if I can do it this way. Use previous. Not want them to use previous. Thought it might. So, and we're going to do the exact same thing as we did on the last one. And that's put our references in. And then complete our second component here. And go up to our arc concentric. Standard orientation. Right mouse button, OK. 2 selected here. To go the other direction. That one. And of course we can also change our component. Not the greatest color choice. All right, and again, you can put the hole through, so just set your practice on this one. And this time I won't bother to locate it in the center. I'll just move it around a little bit and through all. And again, remember, this is penetrating only the assembly. So if we open it up, you'll see that the hole is not displayed on the part level. We can go back and intersect part level. And again, I'll check both of them, one of them, the opposite one. And the hole is there. So the difference, of course, if you look over here, you're going to see our top, front, and right datums. You have your assembly hole. And of course, you can do the same thing here. You can actually go and delete this one. See what happens. I got a feeling you got rid of the hole. And we'll assemble it again. And constrain it. And there's our hole back. Kind of interesting though. Hole did not go through everything. You get the assembly hole here, but we don't have it in the other part now. That's kind of interesting. Yeah, I can't get it. Not sure if we can so activate this. Now our copy and paste aren't coming on for this one. So you'd have to put the hole back in. I was hoping to be able to copy it and paste it. But the main thing here is you do have your traditional placement coincident constraints rather than coordinate system to coordinate system. And it's not wrong to have coordinate system to coordinate system. So two different methods, and again, mainly what you're getting is the ability to see your top, front, and right datum planes in a traditional manner. Also, when you get to your components, because of that, let's open up this one right here, and let's quickly go into a drawing. And you can see your views. Now, what's different about that? Well, in our first assembly that we did, in the top down, what if we did the same thing? I never even noticed I lost my hole on this one. So let's open up this one and go in and create a drawing. And it's going to come back and it's going to say there are no views. What does that mean? Well, if we look over here, we will see there are no views, only the standard orientation, because there's not a top, front, and right datum plane to orient. Okay, now you can create a view, and let's say we want this to face the front, and this to face the top. Okay, and we'll call that the front view. And we'll save it. Okay. So now, let's start a drawing and see what happens. I got a view. So as long as you have a front view defined, it'll give you these, allow you to do the standard views when you get to the drawing. So that's one of the differences. If we go back over to our one of the other components and we go into creating a drawing. It'll give you the views because we created this with the second method where it gives us the top, front, and right, datum, and what we have is all the views are available. So I think this is probably the better way to do it, is to create your assembly and then create 3 however many parts you want. Now what the companies do is they'll have it so it's set up in your Windchill or Interlink, your PDM manager, and the person working on it can check out one of these components. And once it's checked out, they work on it, and anybody else going to the database can see that that part is being checked out and is owned by somebody at that particular point. I think having the traditional datum planes and views and everything else helps in this process when you're doing your design. This completes a mini lecture on top-down design.